Hello, everyone. So we have another AIME problem. So it's the last problem on the test. So we have chord AB, a circle of omega, and then P is a point on that chord. And omega 1, like W1, whatever you name, passed through A and P, that is internal tangent to the original circle. And another circle, omega 2, passes through the B and P and internally tangent to the first circle we have, and those two other circles that is tangent to the first circle has like two intersection, and then P and Q. And PQ intersect at the first circle at X and Y. Assume that AP is given 5, PB is 3, and XY is 11. So based on this, you can just start with some sort of like drawing and kind of use the best one you come up with. And since AP is larger than PB, the circle that W1 is going to be larger than the W2 or omega 2, whatever you name. Okay. So which is why I kind of wanna made that figure immediately without really spending time. So that was right here. So like just imagine this is your original circle, and then the W1, which is going to be a circle that has the longer chord, which is AP is given bigger than PB. So that's just 3, and the other one is 5. And XY is the points on the first circle that we start with. That's the Y and that's the X. And we want to find the distance between P and Q. But I just add some other ones as well, so which I'll explain how we got those in the first place. So first things, we start with the center of the largest circle, which is omega. And then if you have another circle that is internal tangent, that is a bit larger than the other one, then that will have a circle that is going to be somewhere in this region. Let's call this is O1. But when you connect these two circles and when you extend that, that needs to be tangent of, that needs to be the radius of the largest the circle that we start with. And then that needs to be tangent to here. So that's the same reasoning. If you take this point, center of this point and connect with other center and extend all the way to the intersection, that will be perpendicular to that tangency point as well. Okay, so we have those, and that means this is a straight line, and O2 and B is also straight line. So these are something we have. And what I did was like I connect the O1 to O2, because when you have some circles, it's good to connect their centers. So we have three centers are connected, and we did have like Q and P as intersection, which is why we connected the center of the first circle with that Q, and then we connect the other circles with the P as well. Okay. So anyway, this is the figure we have based on those. So the first thing we can just see, AO is a straight line, which is radius, and OB is also, which is why this angle right here and then this angle right here has to be equal, because that's just the base angle of the isosceles triangle. And similarly, O1 is the center of this circle, so which means A to O1 and O1 to P is also radius of the smaller circle on this side. So which is why the angle right here is also the same. Okay, so that is also the same as this one, which is actually telling us this guy and this guy, like OB and O1P, is parallel because these are corresponding angles. And that will force this angle to be same as this one, which we can easily see because these two is the same as these two. So the O and O1 has to be the third angle of those two triangles. So that needs to be the same angle. And similarly, we have another circle right here. So this distance is also a radius, and this is also radius. So which means this triangle and the AOB and AO1P, they are all similar to each other by angle-angle similarity. So let's write those first. So the triangle like AOB, so AOB, so is similar to a triangle A like O1 and then P, right? So AO1P and then PO2 B. So that's similar to the triangle PO2 and B. Okay, so we have those, they are all similar, which is good. And that's why we said, oh, like this guy and this guy is parallel. So this one will be parallel to this one. And similar reasoning, since this angle was the same as this angle, so we know that this one is parallel to this guy, which will force this figure to be, this quadrilateral to be parallelogram. So let's keep that in mind. And there is some progress at least, right? So we have those, but maybe we can write some segments as well. So what else we need to kind of find is just some sort of segments that is congruent to each other. So for that reason, maybe we can start with like O is like the center of the largest circle. If I connect this to O2, so because that's the one side of the parallelogram, so this is the segment is actually equal to O1 to P because that's the two opposite side of the parallelogram. But this is also equal to the O1 to Q. So if I take this guy and connect with this, so let's go ahead and connect. This is also equal to this because if you think about the circle like omega 1, the O1 to Q is the radius, and then O1 to P is also radius. So those three are going to be equal. Okay, so that is something. And similarly, we actually have like O1, which is like this to this segment, which is the opposite side of the parallelogram. These two guys are equal, but that is also equal to O2 to Q, so which is gonna be this segment. Why is that? Because that's also radius of this circle O2. So that is radius, this is radius, those are all equal. So good news is, you know, when you look at this figure now, let me actually write this as a statement. So we have that two triangles are actually congruent. So we can say the triangle O, like O1, okay, and then O2. So that's the O1 and O2. So maybe I should like show the other side as well. So if I connect the O1 to O2, which is, let's say this is the red one, and we have like three sides. So O1, okay, O1, O2. So one side is blue, one side is purple, and one side is red one, right? And the same thing is O1, Q, and O2. That is also the same color. So, which is why I can just say this triangle is congruent to a triangle like, maybe I should keep the orders. I start with O and then O1, so which is this guy. And I can say this might be like this one, like O, like QO2 and O1, right? So Q, that guy, and O2 and O1. So I think that should be fine. And this is the congruent because all three sides are congruent. Okay. So what does that tell us? It's telling us that, you know, we have this segment is the same as this one, and then this segment is the same as this one. So two diagonals are equal, and then these sides are equal, which is we can like call as legs. So which means this figure right here is actually a trapezoid, which is isosceles trapezoid. So which is telling us the O to Q and O1 to O2 is actually parallel because of the trapezoid. So we can maybe show that as well. So these guys are parallel as well. Okay, so what is that telling us? So you know that when you take a center in a circle, so let's say we have a circle, and if you draw the any chord, and if you draw a perpendicular from the center to chord, any chord, so that will be split into two equal pieces. So, but if you are given, there is a chord, like if you take this center and connect a segment to that common chord, because PQ is the common chord of this circle and the other circle. So if you draw the perpendicular from this center to this chord, right in the middle, when you take the midpoint, and then you do the same thing with the other guys, so they should actually match. So which is why the angle right here should be 90 degrees. And since we know this was a trapezoid, so the angle right here is also 90 degrees. So that means O to Q has to be perpendicular, because this is 90, this is parallel to this one. Okay, that is gonna be helpful because we already know like XY is entire segment was 11. So, right, so which means the Y to Q should be half of that, which is like 5.5. So then the other part will be also 5.5. But we are interested like Q to P. So if I call that's like X, okay, so which is like PQ, right? If I call this is, let's say, X, since we know the remaining part was 5, like 5.5, so that means this part will be 5.5 minus X. So if I want to take the other numbers that we had, like this was 5 and this was 3. So I can take the power point with this guy, so which will be 5 times 3. And then this is 5.5 minus X. And since this is X, PQ, and then the other part is 5.5, which is going to be 5.5 plus X. And if you do expand those, you get, this is like 11.5, which is going to be 121 over 4 minus X squared equals 15. So if you do simplify this on this side, so you got 121 over 4 minus 15, which is going to be 60 lesser than this, which is 61 over 4. So I believe that should be our sum of those M and N, so which is 65. So it was interestingly like challenging problem, but when you kind of start a few drawing based on the given information and see which one is kind of the best to use to go forward, and having a couple of circles in one figure is not easier to deal with, so which is why we need to use our protractor and stuff. So especially when you have a lot of circles involved. So that was a bit challenge to start with. After you have that, you probably want to ask yourself, how can you connect the piece of information we are given, and is there a way to find some like sort of similar or like congruent triangle? That usually what we look for when we deal with circles anyway. And the PowerPoints will be another tool for sure. And in this case, we didn't use any other stuff, but there are some other tools that we have, like Ptolemy's theorem and stuff. That's also common, but we didn't have this in this problem. Anyway, so I hope that was clear. I'll see you next time.